Continuing the wonderful world of functions. Here's your standard. What we're really going to focus on here is the linear function aspect, okay? About being a straight line, and then functions that are not linear. Hopefully at this point you are pretty familiar with y equals mx plus b, what the different parts are, how we talk about m as being both rate of change and slope, b as being the y-intercept and also sort of your starting point or initial value, x being the independent variable and y being the dependent variable. So if you're unclear on any of those parts, I would really encourage you to go back and watch parts of the videos that we've done before this, right? 8F1, 8F2, maybe even 8EE5 and 8EE6 to really get yourself a good firm understanding of them. All right, so let's dive right in. Okay. Take a look at this. Let's consider the area of a square, and let's think of it as a function of the side length of the square. All right, so what I want you to do is I would like you don't need to necessarily copy down this part, but put in the sort of the idea of what we're doing, right? Area of a square, and then you can do the side length and the area here. And what I'd like you to do is I'd like you to try to fill in the area values of that table. Go. Okay, so side length 1, what would be my area? Okay, well here's the area, right? If my side length is 1, then it's going to be 1 square unit, okay? Whatever this is. If this is 1 inch, then this is going to be 1 square inch. If this is 1 centimeter, 1 square centimeters. If this is 1 mile, it would be 1 square mile, okay? This is a unit square then, okay? Now let's say I have a side length of 2. Let's say this is 2 miles, okay? Then I'm going to look at this and I'm going to have a 4 square mile area. Okay, 4 unit squares, right? So 1 square unit, 1 square unit, 1 square unit, 1 square unit, 4 square units altogether. Okay, whatever the measurement. Okay, let's say feet, because feet is the one we use a lot when you talk about maybe carpeting, or if you're painting something, or the inside of a house. If you're even looking for apartments, use square feet oftentimes to sort of compare the size of things. Okay, so this is 1, 2, okay, and that means I can say there are 2 rows of 2, which is going to end up giving me a 4, okay? So let's say, go ahead if, well, you should have this done already, so the side length of 3, and if you didn't finish it, then I would definitely pause right now and go ahead and finish. So if I side length of 3, then I would draw another one, right? And it would look something like maybe 1, 2, 3, and then 1, 2, 3, and I'd come up like this, okay? And then I could say 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and I would have an area of 9. Okay. All right. So that's that's that. All right, well, what about 4? If I have a side length of 4, I'm going to get 16. If I have a side length of 5, I'm going to get 25. Okay, so let's go ahead and use this. What we're going to do is I'm going to use this graph, and I'm going to graph the ideas that I have here. Okay, and the numbers kind of give it away. I normally would not have the numbers in there, and I'd sort of ask you to figure out what the independent variable is. But you can see, like, we were changing the side length, and we were checking to see how did the area change. Well, if that's the thing we're measuring, okay, that's going to go on the y-axis, okay? And the independent, the thing that I changed to begin with, right, that was going to be the side length, okay? Okay, this is the independent variable, which is here, okay? That's the thing I changed. Area was what I measured, okay? Well, if I'm going to have a 0, 0, right? Because if I have 0 side length, I have 0 area, okay? And then I'm going to have a side length of 1, and my area is 1. Side length of 2 gave me an area of 4. Side length of 3 gave me an area of 9. 4 gave me an area of 16, and 5 gave me an area of 25. Okay, and you can assume, let's keep going here. 6 is going to give me, what do you think? Yep, 36. Okay, and then we can fit 7 on there, right? 7 will go all the way up to 49. Okay, and if you look at this, I'm hoping as you see this that it's not a straight line, right? We don't have a continuous straight line. In fact, this thing is going to curve, and it gives us this what we call exponential growth, right? Because when I'm squaring it, right, it's growing it's not growing at a consistent rate. Not to say that there isn't a pattern, right? There is a pattern here, but this is growing at a consistent rate. So, or not at the same rate for each of these, okay? It doesn't necessarily have a slope or a consistent rate of change. So we would say that this is a function, indeed, okay? There are no, for every input I get exactly the same output. It does follow a pattern, right? As we can see. But it's not linear, okay? It's a non-linear, it's curved, It doesn't make a straight line. Okay, so in this case, it is a function, but it is a non-linear function. All right, well, let's take that same idea and let's take a look at what happens with perimeter. Okay, so if I take the oops, this should say that's not right. I copied it and forgot to change this. So this one will have a perimeter of 4, right? And then if I have a side length of 2, I've got 1, 2, 3, 4, 5, 6, 7, 8. So then I'm going to have a perimeter of 8. Okay, so side length 1, perimeter 4. Side length 2, perimeter 8. Okay, what about a side length 3? What am I going to get? Okay, well, my side length 3 is going to be 12, right? So if I did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that's going to be 12. Okay, and it really, what you can do is you can see if my side length is whatever my side length is, I have 4 of those sides, so I'm going to multiply it, right? So this would be 16 and this would be 20, and whatever it is, let's say it's called n, right? My perimeter is going to be whatever n is, and we're going to multiply it times 4 because I have 4 of those sides. Okay, and if I were to graph this, okay, I would go 1, right? 1 is 4 and 2 is 8. Oops, I should write in here this is perimeter. Okay, and this is side length. Okay, so 1 is 4, 2 is 8, 3 was 12, 4 is 16, 5 is 20, and on and on and on. If I have 0, I'd have 0 there. And so what I can find here is that let's look and see if does this make a straight line, right? So if I start here at 0 and I move on, oops, I got the wrong arrow here. Okay, start at 0 and I move on. Notice they all form into a line, okay? And my slope in this case is up 4, right 1, which would make sense because my perimeter increases by 4 for every side length that I add, right? So in this case, I do have a consistent rate of change, which is going to give me a linear function here, okay? And if you think back to the function carnival, you should have an idea of which one, right? When we look at, remember the function carnival, right? Function carnival. Okay, so what I want you to do is think about back in the function carnival, which of those had a linear, all right, or at least part of it was a linear sense. Okay, and I want you to try to think about which parts were linear in that. Go. All right, so let's move on. Let's talk about what this means, okay? So I got linear versus nonlinear, okay? So linear, constant rate of change, okay? It's going to have a constant rate of change, so it's going to have a slope, right? A slope, we can call it, constant rate of change is probably the best way. Nonlinear, okay? May follow pattern, okay? It might follow a pattern, but no constant rate of change. This would mean it would have to be the same rate the entire time. The rate can't change. Like you can't travel 50 miles an hour and then travel 80 miles an hour. Then you're traveling at 2 different rates, okay? So that would be nonlinear, the example I just gave. Okay, now we're going to do this idea of discrete versus continuous, okay? And this is just because I want you to start to get in the habit of being able to identify certain features of graphs. So continuous, right? If you think about something that's continuous, it moves on and on, right? So that would be like a line that kind of goes on. That would be a continuous function right there. And we'll do some examples here, don't worry. A discrete one is when you would have a points, right, that follow maybe a pattern, but it's not continuous, okay? It's not connecting. The dots aren't connected. It's only like this, okay? So this is discrete, and this one is continuous, okay? And then increasing and decreasing. Where is it moving up? Where is it going down? Sometimes functions will have both increasing and decreasing, right? So increasing would be going up, decreasing is going down, okay? And sometimes you'll see that something could be nonlinear, okay, continuous, and it could be increasing. It could be nonlinear, continuous, and decreasing. It could be linear, continuous, and increasing. We could have it be nonlinear, continuous, and both increasing and decreasing, okay? And we'll see some examples of some of those. All right, so let's practice a little bit. What I want you to do is for A, I'd like you to answer each of those different parts there. Okay, so actually I'm going to do A for us. We'll start with, and I'll show you sort of what I'm doing, and then you'll answer the questions for both B and C on your own, and I'll go run through the answers. Okay, so the first thing I'm going to do is I'm going to go through here and I'm going to look at A, and I'm going to say, is this a function, right? Well, yes, it is a function, right? For every input, I have exactly one output. If I'd use a vertical line test, none of them repeat. So I do have a function. It's yes, okay? And we're doing A right here, okay? So is this linear or is it nonlinear? Okay, well, it looks like it has a consistent rate of change, right? So let's see. If I go up 4 dots and right 1, okay? And it doesn't even actually matter what my intervals are here, as long as the pattern remains the same. Because if the intervals are all the same, it doesn't really matter. I'm not looking for the rate of change. I'm just looking to see if it has a consistent one. Okay, so it goes up 4, right 1, up 4, right 1, up 4, right 1, up 4, right 1. That's linear. Okay, consistent rate of change. Okay, now let's see, is this one discrete or continuous? Well, this is discrete, okay, it's not a continuous line. And then last, is it increasing or decreasing? Well, I went up and right, so in this case, it's increasing, okay? So it's going to be, yes, it's a function, it's linear, it's discrete, and it's increasing. Good. All right, now you try doing B. All right, so let's look at it. Is this a function? Yes, it is. Pass the vertical line test. Every input has exactly one output. Is it linear? No, it's nonlinear. It's curved, right? Is it discrete or continuous? It is continuous, okay? It follows a line there, okay? It's not a bunch of dots. And is it increasing or decreasing? Well, actually, it's both. It's increasing and it's decreasing, okay? In this point, it's going down, and once you get to 0, now it's going back up. So it's both increasing and decreasing. All right, now let's try C. Go. Okay, let's look at it. Is it a function? Yes, it is. Okay, every input has exactly one output. None of them are repeated. Is it linear? So this is what gets a little bit weird here, okay? It looks like it's linear, right, because it follows a straight line. But notice, it has a continuous rate of change until you get here, and then it changes. So again, it has to have a constant rate of change the entire time. It can't be a line and moving in two different directions there, okay? So this is actually a non-linear function. Even though it looks like a line, it's got to be a continuous line the entire time. I'm sorry, it's got to have the same rate of change the entire time. Okay, it is continuous, okay? And in this case, it is both increasing and decreasing, okay? All right, let's do some more of these. All right, you try doing D. Go. All right, function? Yes, okay? Every input has exactly one output. Is it linear? No. That's not linear. Is it discrete or continuous? This one is continuous. And is it increasing or decreasing? Well, it would be both. Okay. All right. You try E. Okay. Function? Yes. Is it linear? Yes. All right. It's following a consistent rate of change the entire time. Is it discrete or continuous? It is continuous. And is this one increasing or decreasing? This one is just decreasing. Okay, it's only moving down. All right, moving on. Try F. Okay, is it a function? Yes, it is. Right. All the inputs have one output. Is it linear? Yes, it is. Okay, it does follow a continuous a path, right? It goes down one, right one, down one, right one, down one, right one. Okay, keeps doing that over and over again. It's discrete, okay, and this one is decreasing. It's moving downwards. Okay. For time, no, we'll keep going. You go ahead, try G. Whoops. Try G. Go. Okay. Is this one a function? So this one is a little hard to tell. I would actually say I don't think so, because it looks like if I do this, I'm going to hit a couple different points. Okay, so I can't fully tell, but if I would say no. Okay, let's see, is it linear? No, it's non-linear. Is it discrete or continuous? It's continuous. And is it increasing or decreasing? This one is actually just decreasing. Okay, it only decreases. It down, 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 more down, 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 down. All right, try H. Function, yes. It is not linear, it is continuous, and it is increasing. Okay. All right, let's try I. Go. All right, function, Yes. Linear? No. Continuous? No, it's just discrete. And what does it do? It does both increase and decrease. Okay? So if you're stuck on any of those, make sure you bring your questions to class and we can talk about them. Okay? All right, next, what we're going to do here is I want you to use these tables to identify, to represent, or to find which ones represent linear functions. So just in that highlighted one, A, B, C, okay, A, B, C, or D, I want you to find which ones do you think actually represent a function, okay? Okay, so hopefully you had a chance to do that. And actually the answer here is A, let's see, B, and D, okay? This one might be confusing, right? Because it goes 0 to 98. Well, it actually follows a pattern, right? The pattern is it's just 98. I get one input with an output, okay? And it's going to be a line because it's just where y is 98, okay? This one isn't because, look, if you go up 1, this goes up 4. I go up another 1, I go up 8, so this one is out, okay? This one looks like it goes up 2, down 2.5 for every 1. This one goes up 5 for each one of x, okay? So that's why. All right, next I want you to go ahead and I want you to try doing these. E, F, G, and H. You tell me which ones of these are a linear function. Go. All right, so in this case, it is only G, okay? For each 1/10, this goes up 1. Okay, this one goes up 2, this one goes up 2, but then this goes up 3 and only up 2, so that one's out. Doesn't follow a consistent pattern. This one, let's see, 3 goes down 1 for 1, and then it goes, let's see, then it doesn't change at all for here, so that one's out, okay? And this last one is, it goes up 4, so it must stay consistent, right? So then this goes up 4, so this should go up 4 again, and it doesn't, so that one's out, okay? All right, try this one. Go. Which one of those is linear? Okay, and in this case we have K and we have L, okay? Let's see, this one is down 20. Let's see, this goes down 20, up 20, down 20, up 20, down 20, up 20, not down 20. If that was a negative 80, it'd be fine. 3 and 4, 6 and 8. So that doesn't work. That's out. Okay. Over here we go, let's see, it goes up, let's see, x goes up 1.6 and y goes up 8. So it's 8 to 1.6. Okay, and then what does this do? This goes up 1.6, and this goes up 8, and this goes up 1.6, and that goes up 8. So that one's good. All right, there you have it. Okay, you know, I have another one with equations. So I'm actually just going to show this to you, okay? And what I'd like you to do is just take a look at that first one, and I want you to bring to class which of these do you think might be linear and which ones won't be linear. Okay, and we can talk more about this one in class, but this video has gotten longer than I wanted it to be, and we don't need to continue this more. Okay, so take a look just at that first row, bring that to class.